Yes, okay. So let's continue. The chief programmer should select those features to be performed under his supervision, and then the classes should be assigned to class developers. So, team of class owners or developers should do the job of implementing that set of features. Selects features and schedules its iterations according to the overall development plan. And we should remember that each iteration should not take longer than 2 weeks to complete. So the chief programmer is responsible for scheduling the features and make it to the deadline. At any point during this development period, several iterations are being performed concurrently. Some of those iterations are being supervised by the same chief programmer. So we have the iterations that class owners do under the supervision of that same chief programmer. And also we have some other class owners that do the iterations for developing other classes. So we have so many teams of class owners that do several iterations simultaneously. They are composed of two sub-processes, design go processes. The first one is design by feature. For designing, we should form a features team, which includes the chief programmer and also the owners of the classes that might be involved in the implementation of the features. First of all, they should conduct a domain walkthrough, and if there is any reference documents available, they can study those documents. Then they should develop sequence diagrams. Sequence diagrams will show how objects can interact at runtime in order to implement those features. Based on the developed sequence diagrams, they can refine the object model or the class diagram so that the class diagram should support the sequence diagram which is produced in the fourth step. Then they should write class and method prologues for the elements of the model for each one of the classes. In design, we should also do an inspection task, which is performed by the features team for being assured that there is nothing wrong in the model, in the design model. Then the work production package, which is produced in these tasks in this sub-process. This design package includes sequence diagrams, the refinements that we made the object model or the class diagram. And so additional information we can alternative for the assumptions that we made in the design package. The next sub-process in the building by feature. In this sub-process, we should implement the classes and the methods according to the specifications in the design package from the previous sub-process. Each one of the class owners should implement the necessary items. It includes the code of the class and also the codes of testing that class. So we need the source codes and also the unit testing codes. Then we need to conduct an inspection over the code. Before the unit testing or after the unit testing, the team, the developers team, should examine the code to make sure of the integrity and also the conformance of the code to the coding standards of that organization, that corporation. Unit testing is to show classes that are by the functional so on unit tests. They can conduct unit tests at class level. So for each they should write a unit test for that class, and also they can do the unit test at the feature level. So we can write unit tests that can test that feature. The feature level unit tests are prescribed by the chief programmer because the chief programmer has knowledge about all the classes that are implemented to realize the feature. The next step is promote to the build. If the implemented classes are successfully inspected and unit tests, then and pass all the unit tests successfully, then we can promote to the build. The FDD methodology has its own strengths and weaknesses. The first strength of the FDD process is just like other methodologies that we have in the Agile category, which is being iterative and an incremental process. We have iterations, we have builds after each iteration, so we have incremental development. Based on the FDD process is based on a general three-layered architecture. We have three layers of features and feature sets and sets. On structural modeling of the problem domain, we use different modeling in this methodology. It is based on system requirements. We will capture the requirements and also express them as features in a general template that is defined for features. Traceability in this process is implemented through use as a basis because we start at and then we have tests for those we have designed for those features. We will implement those features in multiple classes, so traceability can be tracked based on features. The FDD process is a simple and also straightforward process and the well thought out process. In the FDD, we use multiple models, so it's a model phobia process. It's not like other processes of agile methodologies that try to avoid modeling at all. The next strength is observe process via feature-based modeling activities. So we have seamlessness in this process. The development in FDD is a design-based development. We have a clear-cut sub-process for designing. We have continuous validation in this process. And frequent deliveries once the iterations start. at the end of each iteration, we have a new delivery. We can also manage the complexity at the features level through the layers of features and feature sets and major feature sets. We can divide the big problem uh, into small areas or activities. Okay, for your questions. Oh, so many questions. Okay, Miss Arafiq, let me show you this. Let me show you one picture that I draw for another class on features and features. Okay, let me copy it. Okay, Miss Arafiq, this is an example. When you want to write the list of features, it's hard to write a list of features, so we use a top-down fashion. But if you see, we have features like, for example, it is for selling tickets of an airplane. We have features that are checking the availability of seats, reserving a ticket for seats, canceling a ticket for seats, and checking the type of a seat. These features are related, so they can be grouped as a feature set or activity. A feature set is also called activity. We have other features like checking the time of a flight, type of a flight, and reserve a whole flight. So these features are also related, so we can combine them to create another feature set or another activity. So we have feature set number 2. We have 2 feature sets. And for feature sets or activities that are related, we can group them together into a major feature set or an area. In a project, we can have multiple major feature sets. We can have multiple areas. In each area, we have several activities or feature sets. And in each feature set, we have multiple features. So this is for handling all the features, the big features and the small features. The big features are called major feature sets or feature sets, and the small features of the system are here. We can group them, we can classify them, and manage the complexity. Yes? And another question, promote to the build, to create a new build of the software, to create a new version of the software. Okay? Miss Arafiq, promote to the build means to create a new build. Yes, Miss Arafiq, yes, it's correct. The project has several areas. In a project, we can have several areas. It's just an example of one area, but we can have several areas. Thank you for your good question. The other question that was about the promote to the build. I said that promote to the build means to create a new version of the software. Create a new version of the software. Each new build software. Model phobia Model phobia means we don't want to create models. Okay? Model phobia means we don't want models. Mild, mild, mild means a little, not so much. Okay? So in FTD, we do modeling. We don't hate models, we do modeling, but not very much. Okay? So Miss Arafi and Mr. Al-Hajami. Mr. Al-Hajami, your question on FDD has become an ideal practical approach to long-term project. Mr. Al-Hajami, no, I don't think. FDD is not so common. You're welcome, Miss Arafi. Mr. Al-Hajami, Scrum is more popular than FDD. In FDD, it's very hard to uh, extract practice, and also is used in the industry, so it's a good methodology too. Okay, Mr. Al-Hajami, it's clear. Thank you very much. In this picture, you see uh, mm, a list of features that are um, mm, defined based on the major feature set or area. This is an example that shows us the three layers of in the FDR feature set or an area. In each area, we have several feature set or activity. We have here two feature set or two activity, and each feature set includes multiple features. Each feature set or each activity includes features. And in a project, we can have several major feature sets or several areas. For managing complexity, we try to use a top-down fashion to identify the features of a system. Yes, Mr. Zobaid. We have class owners. We call the developers that are responsible for implementing a class. We call it means that developer should implement that class. Okay? So for each class, we assign it to a developer and call that developer the class owner. That class owner is responsible for implementing the class. Okay, let me show you again. No. Okay, design in building. In building, we have class owners. Each one of the class owners implements the necessary items of that class, implementing that class, okay? No, Mr. Al-Hajj, this in FTD, we have several features, so it's not good for very small teams. Okay, because we have a group of developers, and also we have a chief programmer that is the manager of that team of developers. Miss Arafiq, Miss Arafiq, the features are defined by user. Let me check it again. Here in building the feature list, the feature list are defined by the building feature list. We define a feature list team. The feature list team includes project manager and also chief programmer. Okay, but we get help from the users to create the list of features. The evaluation, Mr. Abid, for evaluation, we have unit testing in here. We have unit testing in here. And for each build, for promoting each build, we also need to do some system testing. So here we have the unit testing, and after each build, we have system testing. Okay, and also for evaluation, we have different inspections. So for evaluation, we have inspection and test. Yes, Mr. Al-Hajrami, yes, we have some old systems that are designed using FDD methodology. Okay, we have processes, we have softwares that are developed based on FDD. Yes, Miss Arafiq. Yes, we can say that almost all of the agile methodologies are incremental and iterative. Yes, it's correct. Yes, Miss Arafiq, it's correct. Okay. Any other question? Thank you. Very good questions. I enjoy the questions in your class. This will help me learn more too. Thank you very much. Okay, if there is any other question, please ask me your question. Miss Arafi, Scrum is the most practiced and most popular one. Okay, we can tell that is the most popular and most practiced one. Okay. Yes, we can say that it's not best, because we don't have the best methodology. Each methodology is good for different projects. Okay, so please consider that each methodology is good for different projects. And one methodology, even Scrum, is not good for all projects. Okay, please consider that. Yes, Miss Arafil. It depends on the application. It depends on the project. It depends on the team. That if we have a big team or small team, or if we have a team that can cooperate with the customer or not. It depends on the budget. It depends on the deadlines. It depends on the nature of the project. If we have a critical project, or if we have a scientific project, using Scrum is not good. Yes, it depends on the application. Mr. Al-Hajami, if you remember from the Scrum, in Scrum we have multiple sprints, and in each sprint we release a new version of the project, and also we will review the process, and we will review the project. So in different methodologies, in each iteration, we will update the project. Thank you very much. On the FDD process, the next slide. I am going to upload the next slide, so please wait until the update is Yes, Miss Aras, it's about process pattern. Yes, Mr. Al-Zubaidi, this is the last session of our classes. Yes, Mr. Zubaidi, chapter 7. Yes, Mr. Al-Yaseri, for some methodologies, we need users that have enough time and enough information to participate in the process. So when we want to choose those methodologies, we should check with our customer or with our user. We should be assured that the user can participate. Okay? Yes, Mr. Zobai, there was a problem. I'm going to upload it again. I hope that it I'm still waiting for the slides to be. Okay, so the slides are uploaded. Okay, if you are ready, we can start this slide. The last one is a small slide. I will upload it again. Okay, thank you very much for your patience. This is the last slide of our class. So let's go into the detail of this slide. In this slide, we're going to introduce process patterns. We have patterns in different phases of software development lifecycle. Maybe the most known patterns are design patterns. We have also patterns for other phases like the analysis patterns. But for processes, we have process patterns too. But what are the process patterns? Are results of applying abstraction to recurring processes and process components. So we use abstraction to create patterns for recurring processes. Process patterns create means for developing methodologies through composition of appropriate pattern instances. So when we want to develop methodologies, when we want to create new methodologies, then we can use instances of process patterns. We can composite those instances and create a methodology. If you remember, for different methodologies, we have their important components of processes. And when we need to develop methodologies, we need to develop process for them too. If we don't know how to process, we can use instances of appropriate patterns, process patterns. And we can compose them together to create new processes. Process patterns reflect the state of the practice and are based on well-established and refined concepts. So using these also use the experiences of other experts that have lots of practices in the software processes domain. The first recorded reference to the term process pattern was made by Mr. Coplien in his landmark paper in 19. Coplien defined process patterns as the patterns of activity within an organization or within a project. We have different definitions for process patterns, but this one by Mr. Coplien is one of the simplest definitions of process patterns. In processes, we have we have process framework that define the steps and tasks and activities in that process. Activity within our organization is one of the simplest definitions for process patterns. Almost all of his patterns are relatively fine-grained techniques for exercising better organizational and management practices. So you can use patterns of Mr. Coplien for exercising better organizational and management practices. And they do not constitute a comprehensive and coherent whole for defining a software development process. We also have the definition by Ambler, which is the author of the only book so far written on object-oriented process patterns or on object-oriented software patterns. This definition is a pattern which describes a proven and successful approach or series of actions for developing software. So again, these the four activities for developing software. And in this definition, we use the successful approaches or successful actions, and we reuse them again to create new softwares, to have a successful development process. AMLR also defines an object-oriented process pattern as a collection of general techniques, actions, or tasks for developing object-oriented software. AMLR defined three abstraction levels. The first one, the lowest level, is the task process pattern that depicts the detailed steps to execute the task of the task process pattern includes steps to execute a task. The next level is stage process pattern that depicts the steps that are needed to be done in order to perform a stage of the process. So a stage process pattern usually is made up of several task process patterns. The highest level of abstraction is phase process patterns that depict the interaction of two or more stage process patterns in order to execute the phase to which they belong. In any process, phases are performed in serial order. Whereas the stage patterns inside them can be executed iteratively. AMLR proposes many patterns of each type, the three types above, complete with detailed steps and guidelines for integrating and shaping the patterns into a comprehensive process. So let's look at, this is an task level called review task. This pattern shows us the steps for executing the task of technical review, which includes these indicating readiness for review, performing cursory inspection. It is required we can have a loop back and then again repeat these steps and then organize the and act on review results. Which progress. It includes understanding model, source code, documenting source code, synchronizing source code with models, reusing existing code and components, preparing code inspection, optimizing code, preparing integration plan, building the software, and integrating and packaging the source code. So this stage example is consists of multiple task patterns for each one of them. For each one of these tasks, we can define a task pattern and use a task pattern instance. The next example is for a phase, the construction phase. In the phase process patterns, we can identify the interaction between different stage phases. As you see here, we have the program process pattern, stage pattern that is shown in this slide. So the phase pattern can show us the interactions between different stage patterns. Here we have the program, generalize, model, and test in the small. And at last, we have the object-oriented software process, OOSP. which include multiple phases, phase patterns, process patterns. We have here the construct process patterns from the previous slide, and we have other phases too, the initiation, delivery, and maintenance and support. So we can use process patterns at the stage level, at the phase level, and the task level to create, to develop a new process for methodology. Mr. Aliosri, this is a very yes, Mr. Aliosri, the ascending order is correct. The highest level is phase process pattern. The lowest level is task process pattern. Yes, Mr. Aliosri, it's correct. Yes, Mr. Aliosri, for each methodology, we should develop a different process. Each methodology is a modeling language. So if you have different methodologies, you have different processes too. No, Mr. Let me see again. Mr. Azobaidi, Mr. Azobaidi, let me show you. Ms. Arafiq, consider we want to create a dress. We use patterns. A pattern for sleeve, a pattern for example, skirt, okay, and so on, okay, okay, Mr. Rafiq. So, for example, we have a pattern like this for sleeve, okay, and we have a pattern like this, okay. We use patterns for dresses. So here we have the process. So here a process. We use patterns. Patterns for phases, patterns for stages, and patterns for for tasks. Okay? Okay, so we have patterns for a dress, for sleeves, for skirts. Here we want to develop a process. We use patterns for phases, for stages, and for tasks. Okay? Is it clear? Okay, so these are patterns. These are patterns. This is the dress. Okay, so the final result is the dress. But for creating that dress, we need these patterns. Okay, is it clear? Is it clear? Okay, so patterns will help us to create the dress. Uh, Patterns will help us to develop a process. Okay? Okay. So to the slides. So those patterns those patterns comprehensive whole. It's uh, some parts. It's just some task or some stage or some phase. It's not a whole. Okay? Like dress, we have patterns for sleeves. We have patterns for skirt, but we don't have a pattern for the whole dress. Clear? Okay, let's continue the strengths and weaknesses. The Ambler's process patterns have some strengths. The first one is that they are comprehensive and have detailed specification document. They have comprehensive specification document. They have a full coverage of generic development lifecycle activities. These process patterns can define iterative and also incremental processes. They have full support for umbrella activities. They are requirements-based development and based on functional, behavioral, and structural modeling of the problem domain and the system. They accommodate comprehensive modeling at all levels, from the problem domain to system objects, and from logical to physical. They use rich modeling language. They use UML in structural and behavioral modeling. They also can use the support of UML for model constraints. Traceability is supported through use cases. They also have some weaknesses. First of all, they are not defined as individual patterns, but they are defined as components of a specific object-oriented methodology. So this will enhance the tangibility of the patterns, but it will damage their generality and also applicability. And they are very complex. The configurability is not addressed, and seamlessness is damaged due to hitches in model mapping. Number of models are prohibitive, and also there is substantial potential for inconsistency of models. You can study more about these patterns in these references. Okay, if there is any other question in these strengths and weaknesses, please ask me. Okay, thank you very much for your for being present and participating in our today. I also want to remind you of your research. Search from the a list of suggested subjects. I will a new version of that list tonight. Give you some sample questions for your final exam. I will upload sample questions for your final exam in the